Going back to the last couple of modules, we defined a bond in general terms as a long-term debt security. We talked about coupon payments being the term that we use for interest payable on the amount borrowed. And we defined the coupon rate, which is the annual rate of interest, calculated as a percentage of the face value of the bond. Finally, we use this formula to calculate the value of each coupon payment. But what if we have a long-term debt security with a coupon rate of 0? In other words, there are no coupon payments. Just like a short-term discount security, the only cash flow from a 0 coupon bond is the repayment of the face value. Therefore, just like a short-term discount security, a 0 coupon bond is also a discount security. You will pay less than the face value to buy the bond. You will pay a discounted amount to reflect the time value of money. In the previous module, we used this formula to calculate the price of a short-term discount security. By definition, a short-term security has a maturity of less than 1 year. We use the variable D to represent the number of days between today and the maturity of the bond. And therefore the price is simply the face value divided by the interest rate factor. To put this another way, a short-term discount security is only held for 1 period, which is for D days, and the R that we use is the interest rate for that period. When it comes to a 0 coupon bond, since a bond is generally referring to a long-term debt security, there is still only one face value, but it is more than 1 year in the future. And when a cash flow is more than 1 year in the future, we need to use compound interest in the financial mathematics topic to calculate the present value of a future cash flow based on compound interest. The R in this formula is not for the entire period of the investment. It is the discount rate for 1 year. We then need to raise the interest rate factor to the power of n to represent the number of years of the investment. So here is the formula for the price of a 0 coupon bond. It's still just the present value of a future cash flow based on compound interest. The only change that's been made is that instead of R, which represented an interest rate in the financial mathematics topic, we use Y to represent the yield on the bond. As discussed earlier in this topic, the discount rate and the yield are effectively the same thing in financial mathematical terms.